Good day everyone. Welcome to our presentation on lipids, the often overlooked yet essential building blocks of life. We all know about fats and oils, but lipids encompass a much broader spectrum of molecules that are critical for everything from storing energy to forming the very membranes that enclose our cells. Today, we'll explore the fascinating world of lipids, diving into their structure, properties, and vital roles in our bodies and the world around us. Let's start with the foundation, fatty acids. They are the building blocks of many lipids, like Lego bricks for more complex structures. Imagine a long chain of carbon atoms, each linked to hydrogen atoms. At one end of this chain sits a carboxyl group, the head of the fatty acid. Now, the key difference, the types of bonds between carbon atoms. Saturated fatty acids. These have only single bonds between carbon atoms, creating a straight, saturated chain. Think of butter, solid at room temperature. Unsaturated fatty acids. These have at least one double bond between carbon atoms, causing a kink or bend in the chain. Think of an olive oil, liquid at room temperature. The length and saturation of the fatty acid chain greatly influence its properties, affecting how it behaves in our bodies and in the environment.
Triglycerides are the most abundant lipids in our bodies and a vital energy source. Imagine 3 fatty acid tails attached to a glycerol molecule like a 3-pronged plug. This structure allows triglycerides to store a tremendous amount of energy, much more than carbohydrates. Triglycerides are stored in specialized cells called adipocytes, which act as our body's energy reserves, providing insulation and cushioning.
Coatings waxes. Waxes are another fascinating group of lipids. They are formed by combining long-chain fatty acids with long-chain alcohols. This combination creates a waterproof coating that protects plants, animals, and insects from water and the elements. Think of the waxy coating on leaves, the protective layer of feathers, or the honeycomb built by bees, all examples of the protective power of waxes.
Now, we'll move into the world of biological membranes, the essential boundaries that define every cell. Phospholipids are the main player here. They have a unique structure, a hydraulic head that loves water and hydrophobic tail that hate it. This dual nature allows phospholipids to form double layer and bilayer with the heads facing in water environment inside and outside the cell, while the tails from the barrier in between this barrier control what goes in out and out of the cell like a gatekeeper. Another important membrane's lipid in the sphingolipid, found primarily in the nervous system. It plays a crucial role in the cell signaling and recognition. Finally, we have cholesterol, a vital component of membranes. It has a rigid four-ring structure that adds stability and regulates membrane fluidity. But cholesterol doesn't stop there. It's also a precursor to important steroid hormones like testosterone and estrogen.
Lipids, especially those that are hydrophobic, can simply float around in our watery blood. That's where lipoproteins come in. They're like the tiny buses that carry lipids through the bloodstream to different parts of our bodies. These buses come in different sizes and shapes, classified by their density. Chymomicrons, the largest, they transport dietary lipids from the intestines. VLDL, or very low density lipoproteins, transport triglycerides from the liver. LDL, or low density lipoproteins, deliver cholesterol to cells. HDL, high density lipoproteins, the good cholesterol. They collect excess cholesterol and return it to the liver.
Now, let's discuss the crucial role lipids play in our lives. Energy source. Lipids are the most efficient energy storage molecules, providing more than twice the energy per gram compared to carbohydrates. Membrane structure. They form the basis of cell membranes, controlling what enters and exits, essential for cell function. Signaling molecules. They serve as messenger regulating various cellular processes like growth, development, and inflammation. While lipids are essential, an imbalance can lead to health issues. Obesity. Excess lipid storage can lead to obesity, increasing the risk of cardiovascular disease and other health problems. Cardiovascular disease, high levels of LDL cholesterol contribute to build-up in arteries leading to heart attack and stroke. Inflammation. Certain lipids contribute to inflammation, which can be a factor in chronic disease.
Lipids are essential for life, playing a diverse range of roles in energy storage, cell structure, and signaling. Understanding their structure, properties, and functions is crucial for maintaining health and preventing disease. By balancing our lipid intake and promoting healthy lipid metabolisms, we support our overall well-being.